Open your fleet's disk usage report. If you've got Chrome running on Windows or Mac OS, every endpoint that meets the hardware bar quietly downloaded around 4 gigabytes. The file is called Gemini Nano, Google's on-device AI model, and Chrome installed it without prompting the user, without prompting IT, and re-downloads it if you delete it. It lives in a folder called Opt Guide on Device Model. Here's what's actually on your laptops, and what you can do about it. A privacy researcher named Alexander Hanf, the writer behind that privacy guy, set up a fresh Chrome profile on a clean Mac OS machine in April 2026. He watched the file system using Mac OS's own event log, FS Events D, so Chrome couldn't hide the writes from its own logs. Chrome started the install on its own, without him touching an AI feature, and finished about 15 minutes later, around 4 gigabytes, landed in a folder called Opt Guide on Device Model, in a file called weights.bin. That's Gemini Nano, Google's smallest Gemini model, designed to run locally on consumer hardware. Chrome uses it for the built-in AI features Google has been rolling out. Help Me Write, on-device scam detection, the summarizer and rewriter APIs, and the prompt API, which any web page you visit can call into directly. Google's developer documentation says the download triggers the first time a user interacts with one of these features. Hanf's machine triggered it with no AI feature ever opened, just an automated browsing session visiting ordinary websites. Chrome's docs lay out the eligibility rule. Windows 10 or 11, or Mac OS 13 or later. 22 gigabytes of free disk, 16 gigs of RAM with 4 CPU cores, or a GPU with more than 4 gigabytes of VRAM, unmetered network connection. That bar matters operationally. An older laptop with 8 gigs of RAM won't see this, but anything from your post-2023 refresh cycle almost certainly does. The on-disk install measures around 4 gigs on Windows, slightly more on Mac OS. If you delete the file, Chrome re-downloads it. Google documents this behavior in its own help page. The only way to make it stop is to turn off the on-device AI setting. So what does this mean for you, running IT? 3 operational angles. The most operational one is endpoint software inventory. You probably have an asset management process that tracks what's installed on managed devices for compliance, audit, or capacity planning. A 4 gigabyte machine learning model arriving silently under a browser profile folder doesn't show up as an installed application. It doesn't appear in MSI inventory. Your endpoint protection treats it as Chrome data. Multiply that across your fleet and you've got terabytes of storage drift you didn't authorize and can't see. Sitting alongside that is the attack surface. In January 2026, Google patched CVE-2026-0628, a high-severity bug, CVSS 8.8, where a malicious extension could hijack the Gemini panel and reach files, screenshots, the camera, and the microphone. It's fixed. The point is the surface. A generative model with system-level access, shipped to every eligible Chrome endpoint by default. The next CVE in that surface hits everyone at once. And Mozilla has formally objected to Chrome's prompt API on interoperability grounds, which tells you this isn't a settled design even inside the browser industry. And quieter but practical. Bandwidth and metered connections. Chrome's rule says unmetered only, but eligibility is measured by Chrome, not by your network. If your remote work users are on a 4G hotspot, a satellite link, or a mobile tether that Chrome thinks is unmetered, 4 gigabytes lands per user. That's a bill, or a throttled link, or a remote worker offline for an afternoon. So, what do you actually do about it? 4 practical moves for IT teams. 1. Set the Chrome Enterprise Policy GenAI Local Foundational Model settings to value 1 on your managed fleet. Value 1 means disallowed. Chrome blocks the download and removes the model if it's already there. The policy works on Windows, Mac OS, Linux, and Chrome OS. The same policy applies to Edge. 2. Audit your endpoints before you flip the policy. Look for a folder called Opt Guide on Device Model inside each user's Chrome profile. On Windows, that's under App Data. On Mac OS, Application Support. If it's there, the model's already on disk. Capture that as a baseline so you know what you've cleaned up. 3. Update your AI usage policy to cover browser-embedded models. The category you have for AI tools your team uses probably assumes staff sign up for ChatGPT. Browser-embedded AI is a different shape. It's installed on your hardware, runs on your CPU or GPU. Treat it as endpoint software, not a SaaS subscription. 4. Watch the next move. Chrome ships built-in AI AP is that any site you visit can call. The user permission gate is essentially, did the user click yes once? The first wave of misuse will be sites using the local model for output they send back to a server. Adversarial extensions and pages targeting this surface are the next thing to track. The deal under the hood has changed quietly. The browser is now a generative AI runtime by default on every desktop that meets the bar in every country it ships. Your job is to know it's there, decide whether it belongs, and make the call before the next 4 gigabytes shows up.
That's Darumatic. We cover AI and IT every week practically for the people doing the work. If that's useful to you, like and subscribe. It genuinely helps us reach more IT pros. Thanks for watching. We'll see you in the next one.